The maximum subarray problem is the task of finding a contiguous subarray with the largest sum, within a given one-dimensional array of numbers. Professor Ulf Grenander was a Swedish statistician and professor of applied mathematics at Brown University. His early research was in probability theory, stochastic processes, time series analysis, and statistical theory. In 1977, Professor Grenander encountered a problem in pattern recognition, where he needed to find the maximum sum over all rectangular regions of a given array of real numbers. This rectangular region of the maximum sum, or maximum subarray, was to be used as the maximum likelihood estimator of a certain kind of pattern, in a digitized picture. Maximum subarray problems arise in many fields, including genetic sequence analysis, computer vision, and data mining.
In today's episode of
Wow! How'd you code that?
we are solving Leetcode's maximum product subarray challenge. The problem statement reads: given an integer array, named nums, find the continuous subarray within an array, containing at least one number, which has the largest product. For example, given an array, consisting of 2, 3, -2, and 4, the maximum product subarray is comprised of elements at indices 0 and 1, for a total of 6.
After hearing of the maximum subarray problem at a Carnegie Mellon University seminar, Professor Joseph Bourne-Cadane quickly designed a linear time algorithm to solve it. Cadane's algorithm scans the given array from left to right. In each step, it computes the subarray with the largest sum. It also computes the subarray with the largest sum anywhere between the first and the current index. As of today, Cadane's algorithm remains the fastest method for solving the maximum subarray problem.
Using Cadane's algorithm as a base, the solution to the maximum product subarray problem is fairly simple. Rather than calculate the sum of each element in the array, this modified solution calculates the minimum and maximum products of each of the elements in the array. First, we initialize three primitive integers: maxa, the maximum product subarray value, max, the maximum product value at the current index, and min, the minimum product value at the current index, to the first value at index 0 in the array. We then define a loop that traverses each element in the incoming array. Next, we determine the product of the value at the current index and the value of min and assign it to a new primitive integer, named min. Next, we determine the product of the value at the current index and the value of max and assign it to a new primitive integer, named max. Next, we set the primitive integer min, to the minimum value of the minimum of the value at the current index and min, and the value of max. Next, we set the primitive integer max, to the maximum value of the maximum of the value at the current index and min, and the value of max. Next, if the value of max is greater than the maximum product subarray, max SA, we reset max SA to the value of max. When all elements have been evaluated, the value of the maximum product subarray, max SA, is returned to the caller.
Do you have a question about this solution? Post it in the comments below. If you want to see more unique videos like this, subscribe to this channel and click on the notification bell to be notified whenever we post new content.
Thank you for watching.
and we'll see you in the next episode of
Wow! How'd you code that?